Hi, I'm Sarah Valencia. I'm standing here representing the four of us, Jim, Erica, and Ryan as well. And we've been taking notes for the duration of the meeting. We just wanted to give you a little bit of a summary. These are our very preliminary findings from what we heard from the presentations and posters throughout the last few days. So we thought we could identify 5 overarching science themes throughout the conference that we heard over and over again. So we heard that people were interested in impact processes, volatiles, volcanism, geophysics and astrophysics, and space weathering. And so I'm going to go through each of these and talk about some of the sites that we heard from you guys that would be useful to visit to answer the big science questions. So first, for impacts, we heard that it was important to establish a precise impact chronology. And it seemed imperative that we nail down both the old end of the impact chronology by visiting places such as South Pole Lake and Basin, and that it was also important that we visit really young lunar sites, such as the P60 basalt unit just south of Aristarchus, or and we also have these really interesting sites, the irregular Mare patches, which have been proposed to be both young and old. So there's a lot of important sites we need to visit to help nail down the entire chronology. The second theme was volatiles. We heard that it was important to understand the source, form, and concentration of lunar volatiles. And this includes both visiting pyroclastic deposits at places such as Aristarchus and Compton-Belkovich, visiting the irregular Mare patches, which could have been a frothy magma type situation, and visiting the poles to visit the permanently shadowed regions and the volatiles contained within. The third theme was to determine the origin and evolution of lunar volcanism through space and time. And lunar volcanism is quite a broad topic. We found that the community still finds it very valuable to visit what we would consider a more traditional Mare basalt, such as those found near south of Aristarchus. While it's young, P60 is still compositionally a pretty average Mare basalt. And then we also need to visit the more unique lunar volcanic regions, such as the Gruithuisen domes, to sample silicic volcanism. And again, the irregular Mare patches come up again. The fourth theme was for geophysics, to constrain the interior structure and evolution of the moon. So we found that we needed to visit some large impact basins such as South Pole Lake and Basin. And we heard from the geophysics community that it was very important to have a global network of nodes, both on the near side and far side of the moon, to answer the questions about the structure of the lunar interior. And lastly, for space weathering, we heard that it was important to examine the regolith formation and space weathering process. Places important to visit for this topic were things such as pit craters, of course the swirls to see the magnetic anomalies, and just getting a global picture of the regolith. We also heard a lot about the technologies that we still need to be able to answer these big science questions. One of the ones we heard over and over again was that we need a communications relay to open up the far side of the moon for exploration. As of right now, it's pretty closed off to us. And without the communications relay, it's going to remain that way. We see some need to have our instruments survive the lunar night. There was discussion about the challenges that come with cryogenic sampling, not only during the sampling and storage, but also during analysis. Automated avoidance, hazard avoidance for our rovers and landers as they approach the surface of the moon, and having that mobility on the lunar surface. The US has never had an independent rover on the surface, so that's something to keep in mind. So what we've done is we have begun to build a matrix of all the landing sites that we heard from the community. The landing sites we heard from the community were important, and we we began to classify them as we heard from this workshop, how they fit into the different overarching themes. And then we began to ask ourselves about the mission capabilities that were needed. Do we have to have mobility? Does this work need to be done in situ? Does it need to be sample return, or are there options for both? And the last thing I'd like to point out, everything in red on each one of those sites contains a potential communications issue if a communications satellite is not available. Places like South Pelican Basin that are on the far side you have to have a communications relay. And some places like Swirls, not all Swirls are unavailable without a communications relay, but some are on the far side of the moon and are therefore unavailable. So with that, I'll leave you with our matrix and look forward to hearing your feedback. Yes.
Hey, a couple comments. I think your impact topic, what you have is pretty much impact chronology. But it's important to understand impact cratering as a geological process. And part of that is magnetic anomalies, right? Can basin ejecta become magnetized? Did comet impacts create those things? So, that understanding fundamental impact processes is doable. Let's see, also, I think maybe a better title rather than swirls would be magnetic anomalies. I think they're the more fundamental geophysical thing that we're going there to investigate. Swirls are among 4 or 5 things that you can investigate at a magnetic anomaly. And I think magnetic anomalies ought to be listed in geophysics also, the space physics, plasma physics, and then again, interior thermal history, ancient dynamo, all those sorts of things are geophysics. So that's my 2 cents
Yeah,
there.
that's great. Thanks for that feedback. That's exactly what we're looking for from the community here. This is how we interpreted these major themes to fall out from the presentations. And so any suggestions you have for wording or things that we didn't accommodate in here, we'd love to hear the feedback. And also for things that are more site-specific, especially if you think that your site or another site is not represented with the science themes, please let us know and we can update this.
I think it might be important to note that, especially for geophysics, the list shouldn't be interpreted as we can only do geophysics at these sites. We want to make sure that everyone knows we can do geophysics anywhere. We have preferred sites, but it's not the same as excluding sites.
Yeah, and that absolutely true. And to kind of incorporate for geophysics, that's why I added that last line, the global network of nodes. And it's just hard to capture that in a chart, but certainly in the final report, that will be made clear.
I just want to compliment the findings here. I just want to say, coming from the commercial sector, this is incredibly helpful for us. This is all very actionable information. We can take these landing sites and the mission capabilities pieces, and we can directly input this for beyond, well, mission 1 and beyond as we plan out our manifest. So just want to compliment the team and also compliment the organizers of the committee that put the whole event on, because this is exactly the kind of information that we were hoping to get out of this. So just thank you, and I just want to compliment you on this.
Yeah, I'll kind of add to that for the report. I mean, these are very broad themes we just threw up here. But for the final report, we do kind of plan on breaking these down a little more specifically, hopefully showing examples of some of these specific sites and what kind of measurements you need to take. So hopefully it will only continue to be more helpful.
And Dan, thank you for that. That was exactly our intention. And so from the commercial side, if there's anything else that would be helpful to include, again, please let us know and we can update.
Yeah, I agree. This is great. I do have a question. So in the mission capabilities, you're specifically referring to the missions as described at this conference? Because,
yes.
I mean, certainly when you say mobility required, I can imagine some missions that would go to some of those places that don't require mobility. So maybe it might be better to say mobility preferred, or when is it really required versus preferred?
Yeah, and that is, we tried to base that determination off what was said at this conference. And that's something we will be certainly examining more as we proceed with the report.
And then I had a second question, and several of the mission concepts would go to large basins and look at crustal stratigraphy, the upper crust versus lower crust. Is that falling into the kind of the impact overarching themes, or is that something that is kind of in between or not quantified there?
I think that's that's something we're looking for feedback on. If the community thinks we need to tweak our overarching things, Clive wants to tell us.
Yeah, I just remember that this is going to be an iterative product. You will get a chance to comment on it. And as more things become available and more people have different ideas, they can be added to this. But this is an iterative product. This is not a document that we say this is it. It's more a living document. So it's something that we've got to get right. This is the start. This is to getting something to iterate from so we can get it better. And think about it that way rather than this is the be-all and end-all and people who aren't here, you're out of luck. No, that's not the way. All right?
I asked a question, same one, sample return mission capability. For the lava tube, what does it mean, sample return? There is no check for the sample return.
For which one?
And which one?
For the lava tube,
Oh, lava tube.
there is no
yeah.
check, sample return. What does it mean?
It's hard to get back out of a lava tube.
Yeah, we just, no one presented any information that indicated we needed to bring samples back from these lava tubes. It was more like an exploration type or other scientific investigations that didn't require bringing samples back to Earth.
But if we can have some sample return from lava tube, there are a lot of information. So
I mean, we're open to hearing that information, just based on the talks we were given this week. No one
yeah,
mentioned.
I
Yeah.
did.
Yeah.
I did. From the lava tube, from the inside lava tube, if we get the samples, then a lot of information such as volatiles and magnetic field data.
Mm-hmm.
And actually, for the geophysics, for the pit and lava tubes, I explained that inside the lava tube, we have a good condition to get the information about the magnetic field and past paleomagnetic field, which means core formation information. So I think from the lava tube exploration, we can get good data for the geophysics.
Okay.
Hi, yeah, under mission capabilities, perhaps you might want to consider adding a column for humans on the surface.
Yeah,
And
so
I don't know whether you'd want to say they were required, but we might be able to develop a metric that says something about how much more effective or efficient it is to have humans doing certain tasks or investigations than to try to use a machine.
Sure, so I think that would be helpful. I think for the purposes of our report here, since this is for delivery to the commercial companies, that seems like that technology is farther away. So we're open to discussions. If we would like to expand this to a much broader category of human applications, we can do that as well. But I think we were restricting our report here more to the robotic capabilities.
Well, it's entirely conceivable that there could be a commercial crewed mission with commercial astronauts doing some of these investigations. So that's obviously more expensive and longer term, but it being commercial should not exclude humans in any way.
yeah, and one thing we're going to do for the final report is look at the SKGs as well, and a lot of those cover a human aspect. So we'll kind of dive into which one of these address specific SKGs, and yeah, we will include the human part of that.
And I guess one of the questions that I don't see addressed here is that the whole kind of like going back to the surveyor challenge, how many data points is enough? How many sites do you want to do? So for each one of these, is one enough? Do you need 3? Do you need 5? Do you need 27? So I think that would be another thing that would be interesting is, and I know more is better. I've learned not to ask a scientist, what do you want?
Stop being an engineer.
What do you need? What do you really need here to draw some meaningful conclusions?
Yeah, and again, for the report, when we kind of dive into some of these specific sites, we will have a thing that kind of indicates a little bit more specifically what kind of things are needed, and that would be one thing to include.
It's essentially the same as said before, but also duration. Do you need more than a lunar day, a year, a month? You know, if you want to have a, sometimes, so in regard to the human side, it's nice to have a human look at the rock, but I don't want to have a human driving around and doing mapping locally. So there are some cases where a rover is superior over a human, so there you can do some, there are some cases for a rover to be better than a human, but otherwise humans are also awesome generally.
It's a good job Jack Schmidt's not here. I think prospecting is rover work, but mapping may be more human. So,
any more questions for this panel?
So I just had a comment, a few comments. So one of them was comm relay need not necessarily be to enable far-side missions. So we've already seen that the loading on DSN and even the ESA deep space antennas, so they're pretty high, and they're supporting missions farther than the moon. So they may be maybe scheduling conflicts, and missions that even want to happen may not be able to contend with that thing, and they may need basically more powerful transmitters to return data at a high data rate on the moon, and hence use the smaller antennas on the ground. So cost may go up, but somebody who can break that even between the moon and the Earth, that might also be a good comm relay to have. The other one is that due to engineering challenges, so some of the commercial missions that may try to demonstrate their capabilities in the near term might not pick some of the more challenging landing sites, but they have publicized their own landing sites. Like Astrobotic, even Team Indus has publicized what the landing sites are. If that could be posted in the matrix, and that could be opened up to the science community as to what can be done there, because we have constantly heard that scientists are very inventive and creative in finding what could be done with what is there. So science is useful from any landing site. So if that could be listed, it would be great. There's another one, which is if there's any direct follow-up from recent mission results that have been published, and if there's a way to put that here, as in priority goals are one, but I think some of the SKGs are getting filled up, and probably there are some more reasons to go there because of recent results that have come up. So if that's a weighting factor or a priority factor, that could be mentioned as well. Thank you.
I'd just like to ask a question about what volatiles actually means, because there's volatiles in lithologies, and then there's ices. And we think there are ices at the poles. There's pretty good evidence for that. I'm wondering, I guess I'm asking the question, is there a reason to sort of clarify the differences? And the reason I'm asking that is I fear that by going to Aristarchus and looking at volatiles in a pyroclastic deposit, somebody thinks they've checked that box off, and therefore, lowers the probability of going to the poles, someplace we've never been and have no samples for, and don't understand. So I'm just asking how we might distinguish between those two things.
So each one of the impacts volatiles, each one of those themes is the broadest we're going to be at, and then we're going to step down from there. So it's very absolutely likely that we can divide out the pyroclastics and the polar deposits as different subtopics within that, and that's just not reflected in this chart.
Okay.
And I'll just point out that we did take these from both the decadal survey and from the SCEM reports, and so in those, there's kind of just the volatiles theme, and so that's where our characterization came from. But yeah, then it definitely will be pulled out.
Following on the other commercial comments, just thank you. This definitely helps make sure that we can provide the services and capabilities that you need. And then one thing I'd be curious about in regard to the experiments that do get done, plume interactions with the soil, like from an engineering perspective, it would be good to know how important that is.
So you're talking to the right person. That is my research.
Oh,
so
perfect.
I will make sure there's some kind of yeah, because you're right. If you've got a static lander that's not moving, and you have a very important measurement you need to do right there, I'll make sure it gets taken care of.
Thank you very much.
Okay, if I could
address something that Rick said, particularly for the commercial people in the room. I think it's philosophically very important not to have a system of boxes that can be checked off as done. So philosophically, we run into this problem whenever we talk about missions, and particularly when it's science and human exploration missions. Scientists go at these problems differently than engineers. Engineers like to check boxes and something's done. You know, they need to build something, they build it, it's done. Science doesn't work that way. Everybody involved in the lunar exploration program has to understand that. It is, you address problems, you learn more information, and you evolve your questions, and you can continue to pursue that. So we should never have something like that's up there and check the box as done. It's not how science works, and everybody involved needs to understand that. So, Rick, I would hope what you said doesn't happen, that somebody doesn't go to Aristarchus and said, done. So philosophically, I think that's important for everybody to understand.
Short comment for the polar region. Perhaps that means a permanent shadow area, water ice molecule detection like that. And actually, a permanent shadow area is a permanent shadow from the sunlight. But from the Earth, some permanent shadow are seen or looked. So please careful. Just a comment.
So I guess there's another term that I'd like to throw out here, you know, that you kind of replace mission with the concept of campaigns, and, you know, think, you know, numbers. So rather than sending a mission to a place and go do that, if you had a campaign of, and if we start looking at economies of scale, instead of building one instrument or 3 instruments, what if you built a dozen? You know, are they cheaper by the dozen? What would it take there? So if we're going to have this capability, this commercial capability to go and dramatically increase the frequency and reduce the cost, then what's the science community going to do to take advantage of those kinds of advances? So I think you need to enhance your thinking a little bit here and think big. I guess that would be my recommendation.
Can I just react to something that Junichi-san just said? Volatiles at the poles does not automatically mean PSRs, okay? The reason we say that is because there's plenty of evidence and plenty of study that's gone into establishing that just below the surface in some locales, you get to cryogenic temperatures. So there can be cold traps that are occasionally sunlit, and that's very enabling for an ISRU mission. Okay, so it doesn't necessarily mean that you always have to go into a PSR. I think PSRs are very attractive because we know that there are, I think we know very well that there are volatile ices in places like Cabeus, for instance, a permanently shadowed region. But from the point of view of exploiting a resource, it's much more attractive to find a place that's clement at the surface but has the resource in the near subsurface so that you can get to it easily.
Yeah, and that's kind of one reason we kept poles. We wrote polar regions rather than something like PSRs, and we pulled the polar regions outside of SPA because they're too different. We're trying, and we'll probably break it down even farther as we go throughout the report.
So if we're filling out X's in this table, under geophysics, as you know, I'm all about gravimetry right at the moment, and so there's a few places where you could add some X's with respect to pit craters and lava tubes, and lunar swirls, and polar regions. It could possibly, there could be gravity highs or lows associated with ice deposits. And I guess Marius Hills, to the extent to which it is a lava tube site as well.
Yeah, so there definitely are more boxes that we could check probably all the boxes for all the sites, you know, which is why we did restrict this table to the presentations that were made at this meeting so that we weren't extrapolating too much from what was actually presented here.
Okay, yeah, that, for what it's worth, those ones are the ones that I listed in my poster.
Perfect.
Okay, can I? Yesterday we had one presentation going to the Hertzsprung Basin. So I think it's better to add that.
Any more questions? All right, well, let's thank our panelists.